Um, this is an exciting session, automated geodesic homes, which equal regenerative living with the world's first ceramic dome. And so what we're going to be talking about today are these essentially dome homes. You may be familiar with them, you may be not. That's okay. This is going to be a new approach, a new way of doing it that includes increase of sustainability as far as materials, biophilia, resiliency, and community. And so I'm really excited to be interviewing our guest today and going through this session. But before we get to that, we do want to give a huge shout out to one of our top tier sponsors, Panasonic Ventilation. Panasonic offers all the solutions for your healthier home needs, from supply only all the way up to demand controlled energy recovery ventilation and everything in between. I've been using Panasonic personally now for over a decade in the homes I've lived in to keep my air fresh and healthy. They have Energy Star certified inline fans to meet baseline ventilation requirements, or you can set up continuous intermittent exhaust to comply with various standards. Energy recovery ventilators ranging from 20 to 200 CFM, decentral or central systems that work even in cold climates help with the best balanced air solution. These are paired with demand-controlled air quality sensors, so they only ramp up and run when air pollution is detected, otherwise run less or low. So check them out over at greenhomeinstitute.org/Panasonic Ventilation to learn more today. So again, welcome everyone to Automated Geodesic Homes, which equals regenerative living with the world's first ceramic dome. This course is brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. We are a small but mighty team of 3, and I am the education manager here, Brett Little, and I will be your moderator today. This session is approved for multiple continuing education units, including our certified Green Home professional designation in all 5 pillars of green. AIA Health, Welfare, and Safety make it applicable to your state-based design or contractor license. Check out the Passive House, Certified Passive House Consultant code that will be sent to you in an email as a follow-up. So again, I really want to welcome our speaker here today, Morgan Biershank. Morgan is the co-founder and the CEO, and is a geodesic home and bioceramic material science expert who delivers intentional, thorough, and concise keynote presentations that inspire audiences to connect with their dreams of a healthier world. He has a background in engineering and program management at Intel. He brings broad technical understanding, entrepreneurial grit, and C-level leadership to GeoShip. His devotion to Mother Nature and making a positive impact on the planet was birthed when he spent 8 years sailing around the world. So, Morgan, welcome, and tell us a little bit more about yourself and GeoShip.
Sure. Yeah, thanks, Brett. Yeah, so I think I mean, a little bit about myself. I really left my engineering career in my kind of mid-20s and wanted to build a house in nature and kind of learn to be an artist. And it's challenging. The cost is, exorbitant. And I took a lot of natural building classes and different approaches to natural building, and ended up restoring a classic wooden sailboat and cruising around the Pacific for about 5 years. And I was traveling around Asia and India for a couple of years before that. And then really started building, I mean, my, brother, dad, grandfather were all kind of in the construction industry, one level or another. And so we started building actually a home for my brother. We were taking down a lot of the timber on the land and milling it on site and using a lot of reclaimed materials and just trying to do it as sustainably as we could. And then really started thinking about, my brother pioneered the CNC mold making industry. So, for like in the R&D department of different boat and kayak manufacturers. And we just really started thinking about home construction from first principles in terms of materials, geometry, and method of manufacturing. And, what will be the most common kind of form of human single family housing, in the 21st and 22nd century, and then really getting into uh, where we are now with GeoShip.
Yeah, great. And thanks for, giving us that background. And I guess, can you tell us a little bit more about GeoShip 2 and the basics of the company?
Yeah. So basically what we're doing is um, molding, injection molding, press molding, casting, depending on the component, um, ceramic composite parts in a factory, and really thinking of the home as a fully integrated product. Right? So in the factory, we're not only casting or molding the components, but we're also doing mechanical, electrical, plumbing systems, cabinets, countertops, walls, loft, the whole home as an integrated product, and going through the California factory built housing certification process. And so one of our actually our CTO, our head of manufacturing, and our head of product engineering were all at Tesla in the early days. Actually delivered the first, I think, 10 Model S's, and our CTO drove the first Model 3 across the country. So we're really thinking about, you know, uh, a similar approach to what Tesla took, in that you're just really rethinking the product from the most, what we call physics first principles, or just like from scratch in a sense, and understanding how all of the different parts interact with one another, and trying to really like design all of those interactions so that you end up with a I think what's never really been done so far. I think now we have the technology to do it at just another level, and really integrating the home as like a third skin almost.
Mhm. Yeah,
So
and so I, the structure here, and I'm looking at this and, trying to think of all the homes I've been in and verified and looked at kind of behind the drywall, behind the scenes. And certainly you've got something a lot different here as far as the shape and how it's coming together. Can you just talk to us a little bit about that?
yeah, I mean, so I guess some people are maybe not even familiar with the geodesic dome. The
Yeah.
geodesic dome is like it's a triangulated sphere. So it was kind of the math to really build geodesic domes was developed and popularized by Buckminster Fuller in kind of the late 50s and 60s. And, it's kind of hailed by the American Institute of Architects as the lightest, strongest, most efficient means of enclosing space known to man. So it there's just this um, kind of a dance of compression and tension through the structure that gives you really high structural performance for a minimal amount of material. Um, and of course, the kind of aerodynamics of the dome also make it more resilient to tornadoes and hurricanes. And there's no kind of moment connections, where columns and beams are meeting to fail in like an earthquake.
Mm.
So there's a lot of advantages in the shape. It also helps a lot from like a productization perspective, in that a lot of home builders that are building homes in factories are end up trying to figure out how to make the wall and roof more similar, right? So you don't uh, just trying to like streamline the parts that are required to put together the home, and the geodesic kind of does that naturally. You end up with a lot of different variations that you can create without major changes to the structure.
Yeah, well, and so if I understand right, typically the typical geodesic domes that were built were really more, if I understand, like a stick build, right, or a site build kind of
Hmm.
approach. So this is, I'm assuming, then kind of a newer approach. Like obviously, modular prefab, that's kind of come all the rage now in the traditional world, even though it's still a small part, at least here in the United States, of construction. But so this is sort of an automation of that stick build kind of dome approach, correct?
Yeah, yeah. So a couple of things there. Even Buckminster Fuller, when building domes in the 70s and 80s, kind of remarked that they're like wooden spaceships,
Mhm.
right? Like it's the right geometry, but just still using old materials. And he kind of estimated that it would be, 50 to 100 years until the material science would really catch up with this new geometry and understanding of structure. And that's pretty typical for a lot of kind of major breakthroughs. It's like it takes the material science has to catch up for it to really be popular. As similar with an electric vehicle, it took the breakthrough in lithium ion battery technology to really make that form factor and powertrain viable. And so it similarly here, this material that we're using is a chemically bonded ceramic. It's kind of some people might classify it as a geopolymer, but it's more of it is technically a ceramic, and it's highly crystalline with covalent and ionic bonding. And the
Yeah.
word polymer is kind of the opposite of a ceramic, but it still fits in the geopolymer kind of camp. So all those, I, we I think the core materials that we used for construction basically come down to like wood, metal, concrete, petrochemicals as like broad material families.
Yeah.
And this is really a fifth family of materials, these kind of geopolymers and chemically bonded ceramics. And and we always it's really it's a ceramic composite, right? So think of the ceramic as like the matrix, and the fiber, which is either basalt fiber or steel fiber or carbon fiber, depending on the component, or hemp fiber, is basically integrated through a ceramic matrix. So it's a composite in that sense.
Yeah. And on the note of the materials, I think about what is typically the number one enemy of homes? It's water, right? And we see these homes, even new construction homes these days, we see all of these problems with water entry, water penetration getting in, and maybe in most cases, the rot and the issues occur much later on, but sooner than you would expect for a home to stand. And otherwise, you get the secondary issues with those is, of course, mold and mildew, uncomfort with humidity issues. So, how does this material, if any way, deal with that or handle that?
Yeah, I mean, well, it's a ceramic, so there's nothing for mold to grow on. There's no organic material for mold to grow on. One of the things Brett mentioned earlier around factory built housing. So, so far, usually factory built housing is like you're building a module in a factory and setting it on site. Our CTO, the last company was with, was to our knowledge, the first company that received factory built housing certification for a panelized product in California. So that means essentially we're making components in a factory, and then we're treating the on-site assembly or on-site installation as like our general assembly process. So there's no electricians or plumbers required on site. All of the mechanical, electrical, and plumbing systems are basically integrated into the product and are kind of plug and play on site. And so the inspections, most of the inspections are done in the factory. You just have like a house to ground initial and final inspections done on site. So that really opens, like our go-to-market product is a 2-bedroom, 2-bath, 1,600 square foot ceramic geodesic dome, which we're just finished the engineering of and are making all the components and kind of moving some equipment into the factory here to install the first one at the end of Q1. So far, we've just built kind of smaller prototypes that are not fully integrated homes like this. So I think that's a key point in that we're basically making a panelized product in a factory that is assembled or installed on site. And the way the installation works, we're essentially engineering for like a crew of 4 to 6 people, like GeoShip installers, to show up and do the entire from once the foundation is set and the utilities are run, like the entire home. And we're aiming for like 3 to 4 weeks initially, and then be able to get that down to 1 to 2 weeks. And that would include all of the cabinets, countertops, floors, like certificate of occupancy ready in 2 to 4 weeks.
I got kicked out there for a second, so if you're repeating yourself, let me know. But I think I get caught up where you're at here. What about the mechanical systems? Are those getting installed in the field or in the factory?
Most of it is done in the factory. There,
Yeah.
it's basically what's done on site is essentially plugging things together. So everything has to be really well labeled, and no like wire stripping on site.
Hmm.
And it's all basically PEX systems that are harnesses that are developed in the factory and then installed on site.
Sure. Um, and kind of getting into the design again a little bit here. Obviously, it's if we can get homes to, I guess a lot of the homes that are typically built these days are trying to, if anything, sort of resist the sun, right? So they're thinking about it, not allowing the sun to at least overheat the homes, especially in warmer climates. But a lot of times I see homes it's really just like, yep, we understand it's there. Let's just keep it away. But can you talk to us a little bit about the design intent of these homes, perhaps to, work with the sun a little bit?
Yeah, so we have part of this, it lends itself to just the geodesic form factor in that the wall and roof are kind of one, but it's like around a 44% glass to floor area ratio in the first our go-to-market product that I described earlier, and essentially even with that level of glass in it, we're still you know operational energy efficiency. It's a very tight envelope, and the ceramic reflects over 80% of radiant heat. There's very little kind of thermal bridging through the ceramic
Yeah.
strut and frame system. And the insulation material is a cellular ceramic as well. So it's like you assemble the entire structure and then you basically fill it with this shaving cream kind of consistency. That's a way to think about it. Cellular ceramic material. So I mean, the window treatments, we'll have options for like mechanical blinds or electrochromic glass or kind of smart tinting glass. And people is another kind of aspect of designing the home as an integrated product, in that as people customize the home in the digital space before it's built, you'll be able to see very clearly based on the orientation and location, planned orientation and location of the home, how putting a window in this area will affect your, heating and cooling costs, and just be able to kind of balance those variables as you design the home.
Yeah. So, speaking of heating and cooling and costs and obviously trying to take advantage of passive solar and heating, what are some of the operational energy and carbon targets for these homes? Are you looking at, a specific code, or you've got, on one hand, you've got sort of the passive house movement, which I think a lot of our audience here realizes, you've got super low air leakage, super tight envelope, low energy usage needed from the heating and cooling system. And then you also have the sort of net zero movement, where again, you have nearly passive house design, and then you make the rest up with solar. So like, kind of what are the goals for these homes from like an overall energy efficiency approach?
Yeah, basically we're aiming for like passive house standards.
Mhm.
you know, tight envelope, all mechanical air exchange,
Yeah,
um, and initial thermal analysis were be about 60 to 70% more efficient than kind of your conventional home, and
sure.
that'll really depend heavily on uh, the window configuration as well as
Right.
the size of the insulation cavity. We'll have a couple of different options there for different climates.
And maybe I missed it, but what kind of insulation are you typically targeting for these types of homes?
A cellular ceramic
Oh,
insulation.
okay. And what is the is there like a specific R value on that per inch or
Uh, it varies a bit depending on how dense it's pumped, essentially, but somewhere
yeah.
between 4.2 and it also depends a lot on the measurement apparatus. So it's a pretty friable material. So the typical kind of box test, you end up with the material breaks down in the box sometimes, and you have uh, erroneous readings. So
Hmm.
when they do like a needle test where they put two needles in it and measure the heat transmission between the two, we get better R values, like up around 5.5 or 6.
Okay. Um, and the air leakage with these kind of units coming together, I mean, this is tight, right? I mean, this is going to prevent that air transfer.
Yeah, yeah, it's very
Yeah.
tight envelope
Um,
because not only because it's all sealed up with the
yeah.
ceramic material, but also you're pumping that insulation cavity, after the home is assembled and
Right.
sealed up. So it's kind of a double seal there.
Right. And then kind of going back to that, so I asked that question about heating and cooling, and you're saying it's getting installed. Um, but what kind of systems, are you looking at? Are these heat pumps? Are they or are they, dual fuel systems? Are they radiant? Are they mini split and ground source, air source? Like what are you kind of thinking for the technology, or is it kind of just depend on the location?
It definitely depends on the location. Our
Yeah.
Here in Nevada City, our kind of initial installations will have heat pumps, just
Hmm.
mini split systems.
Okay.
Um, and part of what we're building is this kind of platform to be able to integrate a lot of different third-party
Yeah.
systems into the home. And so,
Yeah.
yeah,
And what about, the ventilation strategy for these types of homes? Is there going to be, I see you've got a sort of passive solar component. Is there a passive ventilation? What's kind of thought through the mechanicals for the ventilation?
uh, we're still designing those kind of details a bit on the ventilation, but basically the geodesic form factor, you
Mhm.
essentially have these natural convection patterns. So you want uh, vents down low and up high,
Yeah.
and air exchange system.
Okay. Now, operational carbon, right? Everyone knows getting to net zero. But once we start to lower that operational carbon and start to hit those passive house standards, we realize our carbon problem now is on the materials themselves, right? Otherwise, is what we call embodied carbon or upfront carbon. So, can you tell us a little bit about, what kind of carbon impact these materials have in their construction? What they're being made out of, their transportation, recyclability, all of that.
Yeah, well, the transportation definitely varies a lot depending on uh,
Sure.
where the home is manufactured and installed. But basically, the ceramic material is about uh, 50 to 60% lower carbon footprint than Portland cement, and we're using a very not very much of it. When you look at the um, just it's like 1,600 square foot home is about 19 tons of material, including the everything that's in the frame, the shell, the insulation, the interior walls, the loft, the cabinets, countertop, like all these things that we're casting from ceramic components is about 19 tons. And so our embodied carbon calculations are, somewhere between 70 and 90% reduction. compared to a conventional wood frame house. And about 80% of the carbon that's in the shell is really related to one key raw mineral that is calcined at about 1200 degrees.
Mhm.
And it's a potential to have a kind of a light burn version of that that's calcined at a 700 degrees, which would then
Yeah.
cut the carbon footprint by another 70%.
Yeah.
Uh, and there's also one of the reasons we're excited about these materials is there is kind of an emerging um, regenerative raw materials industry
Yeah.
to around the materials, and that 2 out of the 4 key raw ingredients can be reclaimed from saltwater desalination
Right.
processes.
Yeah.
Another one can be reclaimed from wastewater treatment plants.
Sure.
And um, the ceramic material, it is technically an inorganic polymer. So it forms molecular bonds with like wood and with metal and with other natural materials. So there's a lot of different aggregates that can be utilized. For instance, with Portland cement, you can't use sand from a beach because of the salt, right? But with this material, you can use like beach sand,
Right.
and it doesn't cause the corrosion on the steel. We don't actually use steel in the panel, but even if we did use steel,
Yeah.
uh, this material actually it's revolutionizing the steel coatings industry right
Mhm.
now, where you spray it like a paint and it alloys the top layers of the steel and gives you kind of a 2 layers of corrosion protection.
And you were mentioning a particular component, say it again, that needed, upwards of over 1,000 degrees or maybe 700 degrees. What was that again?
It's magnesium oxide.
Do you know? I know like a lot of these, in my limited knowledge of industry, obviously electrification of that kind of heat is nearly impossible, but I've heard maybe green hydrogen is a way to do it. Is that something that's being looked at?
Well, it's lower temperature than Portland cement is
Okay.
calcined at, right? So it's not that high, uh, and there's a lot of for sure. There's green uh, technologies that can create that heat,
Get to that
solar
level of heat.
smelters, and
Sure.
yeah,
Okay.
and there's such a I'd also say that there's a lot of different
Mhm.
chemistries that could be substituted into the process. It's a geopolymer. It needs to cure at room temperature. We need relatively quick demolding times.
Yeah.
And there are an, an array of different chemistries that could work in the process depending on what's available locally and what makes sense for the basically the geography.
Sure.
But but I think really foundationally what we're doing is this. You have a geodesic form factor, so it's the most efficient means of enclosing space, and you're using
Yeah.
earthen materials, geopolymer materials to uh, mold components. So that enables you to really engineer at a molecular level the
Mhm.
chemical composition of each component and how the fiber or the basically tensile reinforcing is integrated into each component. And of course, you're controlling the mass, you know, optimization of each component. So it's like using sustainable materials to engineer the world's most efficient structure. So that's where we really think that as this technology scales, I don't think there's any way that you can build a home in through mass production that is more affordable and sustainable kind of at scale. Of course, there's a lot of ways to, if you're building homes from like the dirt on the site and whatnot, there's more sustainable approaches. But I think from like a
Yeah.
manufacturing perspective, this is really one of the ultimate homes. And there's a lot of really exciting benefits to it outside of, so I think you're about to ask about resilience. I didn't just saw that.
Yeah, yeah. Well, and yeah, and so I mean, and you kind of hinted at this at the beginning, but maybe in my mind, I'm kind of thinking resiliency, longevity, durability. But on that resiliency side, we know that climate risks are increasing here in West Michigan, for example. We just got slammed with a very late heat wave. we also got slammed with a storm that literally was just a windstorm, and it just knocked things all over. And we know that wind is increasing here, and heat to some degree, but all over the country and the world, we're having wind, we're having driving rains that are going to damage buildings, floods, you name it. What ways is this going to be resisting, keeping people safe, and durable from this changing climate?
Yeah, well, I think you know, the material itself, there's nothing to rot, nothing to corrode, nothing for insects to eat, nothing to grow mold, nothing to burn, nothing to even emit smoke in a flame, no like
Sure.
toxic material, toxic fumes being released.
Yeah.
Um, and the form itself is resilient to hurricanes and earthquakes and tornadoes. So I think the combination of materials and geometry really give us kind of next level resilience qualities that, and there's no like roof to blow off in a hurricane. Um, the glass can be made hurricane resistant too. So we'll have kind of a Miami-Dade, package at some point here that we'll be able to offer that will just give you even more impact resistance essentially and debris resistance on the glass and the ceramic. And I mean, we're an hour outside of Truckee here in Nevada City, and it's the highest snow loads in the country there. So we're engineering for high snow loads as well. Not sure if looks like maybe Brett froze again. Can people still hear me?
Yeah, I can hear you.
Okay. So let's see.
Yeah.
What would Brett ask next? I think let's talk a little bit about the kind of the health and wellness qualities of the ceramic geodesic dome. So a little more on the material science. We call it a bioceramic because it is literally a bioceramic. It's used in the human body for bone repair, and the chemical composition basically mimics human bone. So it's has calcium and potassium and magnesium. It is really close to the same chemistry as human bone. Um, and the geometry itself is not only, the geodesic form is also this ancient flower of life pattern in 3D. So it just kind of resonates with a sense of beauty and proportion and balance. And so it's biomimetic in that sense. The materials are mimicking biology, and also the geodesic is, after Buckminster Fuller kind of popularized it, they actually found the virus capsids that like the protective protein shells that surround viruses, like carbon 60 molecule is a geodesic form. So it's really foundational. The geometry and materials are really foundational to nature. And so we're engineering the home to really essentially restore the natural conditions that humans evolved with on Earth. So eliminating the toxic materials, having more of a connection to the earth on the floors, so like grounding or earthing floors, natural spectrum lighting, so you have light coming in from all directions, kind of like you would in nature. And also there's kind of this next level definition of success in architecture that is really interesting from, we'd say, like the biogeometry or biological resonance. And basically that comes down to the combination of high dielectric materials and geometry that kind of focuses that energy into the center. So high dielectric materials basically means materials that are not conductive and not insulative, but actually generate an internal charge field, kind of like the capacitors in our electronic devices, high dielectric. So this ceramic is a high dielectric material. And when you combine that with geometry that essentially focuses that into the center, you notice in a geodesic dome, and we do a lot with the texture of the wall panels and the interior design to basically absorb sound, but naturally it wants to create just kind of this sweet spot of sound in the center. And so that energy is being centered, focused into the center. And this is really the kind of the principle, the core principles we're seeing in a lot of these ancient kind of temple building approaches. Like, why do they build pyramids and stone circles and these, ancient cathedrals, the Vastu Shastra out of India and kind of biogeometry out of Egypt? Like, what are those principles that they're applying? We're really integrating that into the bioceramic geodesic dome. It's kind of like, I think it's kind of funny. Like, if humans were to grow shells, I think they would be bioceramic and geodesic, right? It's just like optimal use of material to enclose space, and it's mimicking human bone. And I think the potential here is that, in the future, we'll judge how well an architect did by putting a plant in the room and seeing how well it grows, by measuring the rate of seed germination in the space, by taking a picture with a biophotonic camera, or what they call gas discharge variability. It's basically measuring the efficiency of charge distribution in the space. It's just, I think we're kind of knocking on the door of a new definition of success and kind of wellness architecture.
Yeah, no, that's great, and thanks for giving that full background and that detail. And that kind of leads me into kind of thinking about where this type of technology and this type of idea is going to be deployed. What is going to be the use type of it? Is this sort of one-off single family homes? Is it for any kind of commercial enterprises outside of just living? What about townhomes or multifamily housing, urban versus rural? Like, where does this kind of technology help people in what kind of different living situation or setting?
Yeah, so everything from single family homes to like retreat centers, spiritually, ecologically focused retreat centers is kind of one of our go-to-market strategies, because it just kind of creates the experience for a broader range of people to kind of experience the architecture. But I think, ultimately 80% of new construction is in new communities. So that's definitely where we're focused, is what we would call, instead of a housing development, I think in the future they're more like villages. And today we're still basically building housing communities in the same way we were before the internet, and that developers and banks get together and buy land and build houses on spec and sell them to people. And I think in the future there will be more participation by the neighborhood in how not only how the homes are designed, but also how the village is designed, and sort of the culture and the art, like creating an aesthetic legacy together that we're leaving for future generations, that just kind of expresses our values as a community. And that some people, when they hear that, they think, well, it's like a commune, right? And I think there's like two ends of the spectrum. Like, you're just typical kind of spec neighborhood versus like a commune, where a kibbutz in Israel, for instance, where it's just like everything, all your finances, everything are completely intertwined. But there's a huge spectrum, between those two things, and that's what we really want to open up through this village building platform, is like different templates that support different levels of kind of cooperation within the community. But the one consistent thing is that the people who are living there are participating more in the design of the village, so that we can create something that is like, an aesthetic and cultural legacy, and then also really learning to be stewards of the ecosystems that we're part of. So building homes that are integrated into the local ecosystems, and there's a certain like just understanding and responsibility of people living there, that they're kind of the gardeners in a sense of the ecosystems that we're part of. And I think, the changes that are happening just culturally and technologically in the world today are creating the opportunity for more people to live closer to nature and closer to community. And what that looks like, I think, is more on the like regenerative village living side.
Yeah. Well, let's at this point now get into a couple questions from the audience. And real quick, before we get into those questions, just a reminder to everybody that yes, this session is being recorded and it will be available on our YouTube channel in the next couple of days. So you can either wait and go there in the next couple of days and find it, or you can go there right now, click subscribe. You'll get an instant update when it's available. And if you can help share that online with friends, colleagues, or watch anything you missed, you can rewatch it again. For those of you watching this in the future on demand, not right now, you need to take your quiz with an 80% passing rate, and then you will receive your continuing ed. For those of you here live, check your spam at certs@gutenbergcerts.com. And as long as you've been here for the entire 1 hour CEU approved hour, you will receive your certificate. Take that survey that pops up at the end when we close out too, as we certainly want to hear from you and what your thoughts are. Plus, you have to put your AIA number in that if you're reporting your AIA. And as those questions are coming in, just a real quick reminder, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, our over 350 members, thanks to them, and our top tier sponsors like Ream, Build Equinox, Panasonic. They're all making products to help us live more sustainably. So what I'm going to do for this session is we're going to actually ask some folks to unmute and just kind of ask their question, a little different than we normally do. But David, you're on right now. If you can speak up, can we hear you?
David here.
Hey, David.
Yeah. Hey, no, I was just asking questions about potentially building codes and loads, and you've answered most of that in the question boxes are going through. The only other thing I wanted to know is the dome seems to be able to project almost a two-story full mesh, but I looked at your website and you just add domes and smaller units onto the bigger one, and that's how you create essentially a larger structure. I just didn't know if you can actually create a two full floor loading case and go upwards instead of going outwards.
Yeah, our so the 36-foot dome that we're going to market with first is 1,600 square feet, and that is 1,000 square feet downstairs and about 600 square feet upstairs. So there is like a partial second story. There's about 60% of the space of the first story. And yeah, you're right. The geodesic, just the kind of sweet spot in the size is around 35 to 45 foot diameter, maybe down to 20 foot too for like smaller structures. But when you want to put a second story in, usually around 25 to 45 feet is ideal. And as you get up beyond that, then you start to either need to put a third story in, or you get to something less than a half a sphere, and the walls start coming in more than what's ideal.
Sure. Yeah, structurally, I'm just looking at it as an engineering perspective. How do you take the loads and distribute it to where you need to have it resisted, especially with all the other forces where you're at up in the mountains up there in Nevada City. So with the snow loads and stuff, you've got other things going on. So just curious. Those are the questions I'm trying to figure out how to stack everything if you need to in the future. Thank you.
Thanks, David. We also have Zach H. If you want to unmute, you should be able to now and ask your question real quick. Hauser. Are we able to hear you, Zach? well, let's move on real quick while Zach's working on that. Christina, good to see you out there. What thoughts do you have?
So I had one comment and two questions. I think you might have answered my question about whether microfibers in the ceramics is possible. I heard you say that it is to give it tensile strength. I also wanted to point out that Nadir Khalili was making ceramic domes back in the 1970s. He's an Iranian architect, and I put a link in the chat so people can look at that if they want to. Those were actually brick homes that got fired from the inside to turn them into ceramics. And then the last thing was wanted to know what your thoughts are, how you propose to shade the windows in the summertime to prevent overheating.
Yeah, so for sure. Khalili, I'm forgetting pronouncing his name.
Nadir Khalili.
Yeah, for sure. We're one of our co-founders is really coming out of his kind of schooling and background.
Yeah.
And I think so. Basically, the way we deal with the window treatments is mechanical blinds, electrochromic glass, or smart tint, depending on kind of three options depending on the window and the customer.
So those like interior or exterior shading?
Interior.
Yeah.
All right, thanks, Christina. We have our one of our board directors, Debbie Coleman. Debbie, can we hear you?
Yeah, can you hear me, Brett?
Yeah, hey.
Hey, yeah. So thanks, Brett, for coordinating this event, and of course to the speakers. This is very interesting. So, and I apologize if I missed it, but regarding the foundation, are you looking into tying it into some type of possible below grade foundation where you could actually use some of the cooling aspects of the earth, or possibly for additional storm shelters and any kind of extreme events?
Yeah. So we're engineering initially for basically a slab foundation, but there are a lot of different foundations that could, basically all the same foundations that we're using for conventional housing could be applied to the ceramic dome. One of the, like as the technology advances, we'll really be like engineering the foundation too as part of the product rather than just putting it on a slab. So it's kind of an easy first step, but ultimately there's a lot of opportunity to build foundation systems that are that utilize the cooling and warming properties of the earth, as well as just reducing the carbon footprint and environmental impact more.
Yeah, super. I love hearing that. I mean, I could see a type of, well, just to use another term, insulated concrete form foundation, but maybe that was manufactured by you, so it would all be installed within the same system.
Yeah, exactly. We're basically pumping I mentioned we're using a cellular ceramic material to insulate the walls. Well, the same kind of cellular ceramic material could be used as a sub-floor foundation / insulation layer.
Okay, thank you so much, Morgan.
And I want to follow up on that because, obviously looking at this, I see clearly slab on grade, but then I think about factory built homes. Typically the response to factory built homes is no, we can't do slab on grade. So how are you able to kind of make that happen when typically that industry is saying that's not really something we can do?
Yeah, I think it's because we're engineering the home as a kind of integrated product where all of the mechanical, electrical, and plumbing systems are basically mostly packed into the interstitial floor and the interior walls. So we're trying to kind of decouple the structure from the foundation as much as possible, which just enables us to build on a variety of different foundations.
Okay, yeah, that makes sense. All right, David G, you are up next. Can we hear you?
How's that? Am I coming through, Brett?
Yeah, I got it.
Great. Well, first of all, thank you so much for hosting this event. And man, as an impact investor hunting for valuable investments in sustainable building materials and design strategies, et cetera, man, I wish I discovered GHI ages ago. So I just wanted to do a shout out. What a wonderful organization. And hit me up, please, with my subscription or my attendance digits so I can become a sponsor. We've got quick comment is just that I don't know if anyone else here has had the pleasure to visit GeoShip, but myself and my diligence team were honored to join a group of many other individuals and visit GeoShip and spend a couple days with company leadership learning about the approach and all that. And I just wanted to just say, you know, I've done similar visits with some of the competitive strategies, and I'm not here to kick tires. I think we're all working together to innovate, but I'm just so excited to have these opportunities with folks like Morgan and the team he has at GeoShip to be able to gather and learn how folks are trying to solve the hard problems associated with decarbonization and detoxification. And there's all the other, you know, obviously maybe softer, harder problems like, you know, unhoused humanity and our capacity to roll out sustainable housing at scale, et cetera, et cetera. But I just wanted to say, you know, as a career impact investor, if anyone has any, you know, maybe I'd be a better follow-up for you guys if you want to look at specifically the funding of innovation side of things. But I can tell you I had a great experience with this company, really a tremendous team, extraordinarily sincere. And having been a stakeholder in another domain of innovation for years, I'm used to looking at the viability of bench science and engineering capacity and looking at the hard numbers of rolling something out. Unfortunately, as we all know, in today's highly consequential, kind of unforgiving capitalistic environment, you not only need a combination of brilliant people like Morgan with a vision and the engineering chops at the origin of things, but somehow you have to survive your own early days of, you know, funding yourself and getting to market. So I just really wanted to just briefly sing the praises of GeoShip because I'm a touch the light switch 6-7 times kind of OCD diligence guy, and we just have a fantastic experience of what these guys are up to. And we visit, you know, Boxable. We visited, you know, the folks doing things like prefabricated, you know, the Kateras and the plant prefab people, the Icon, the Wasp folk. I mean, we really have done a tour, and everyone is, you know, there's a lot of good intention out there. But right now, for those of us who see the criticality of part of this, not just being better housing for people who already have houses, but also just the percentage of humanity that's not housed and underhoused, and the viability of a strategy that uses materials that are non-toxic, sustainable, produces, you know, high quality, safe homes at a much more affordable price point, and also addresses the labor issue. Can we empower tens of thousands of individuals who are hunting for meaningful work with the skills to do something this meaningful? So that's just a little bit of I promise you more. I'm not paid by Morgan to join a call like this, Morgan. I'm sorry if it makes you blush, but you know, I've been at this a while, and I just thought I should give an independent view.
Yeah, thank you so much, David. Really appreciate it. It's you know, I think we look at what we're doing as something that is sacred. I mean, really re-engineering the home and the way that we build our communities, from the design of the community to like the social structures of the community. So that's one of the reasons why we've always treated GeoShip as with the intention to ultimately decentralize. So, you know, my co-founder and I feel like we have an opportunity to build like perhaps one of the biggest companies on earth in the future. I mean, the market is that big, and the techno-economics of this ceramic geodesic dome are that powerful. And so ultimately we see, the world that we want to be part of is one where companies are purpose-driven and more decentralized. So they're really serving multiple stakeholder groups, from nature stewards to their customers to their employees and the investors. So really creating more decentralized, purpose-driven ownership and governance structures. One of the ways that we're doing that is, of course, we're not just going out and raising venture capital. We're connecting with impact investors like David, as well as doing equity-based crowdfunding. So really it's kind of amazing that it was illegal for anyone who wasn't an accredited investor to invest in a private company previously, up until about 2016. And that's where most of the wealth in the world really comes from, like these private companies are creating technologies. So all of our funding so far has come from impact investors and from kind of everyday people who are investing a few $100 or a few $1,000.
And I think, do you still have another second here for another question, Morgan?
Sure.
Yeah, so I think one of the kind of questions that are coming in is, how, I guess, the question, of course, is always, well, how much does this cost? And, anytime you're talking about construction, there's cost per square foot, or maybe there's cost relative to a traditional code building. So you can answer it however, but can you give us a little sense of that? I mean, maybe I missed that, or maybe some folks in the audience missed that answer previously, if it was there.
Yeah, I mean, our go-to-market product is it's $190 a square foot, and that's like initially, and at scale we're aiming to get down to about $100, just under $100 a square foot. And this is that's not including land and site costs, but it includes the installation, and it includes all the fixtures and finishes and electrical and mechanical systems.
And I know that under inflation, or go ahead.
Yeah, let me just add in there, and the a lot of our most enthusiastic customers are pretty wealthy individuals that are just like looking for the most healthy and sustainable choice that they can find, and they want to live outside the box, or like curves are high on the list. So the intention is to create a product that can be a low base price, and then a lot of different options that can be added on, so you can kind of go from one end of the extreme to the other to be able to serve people at all different income levels.
Yeah. And I know, like, with the sustainability targets you're trying to reach, for example, it sounds like, meeting the Department of Energy's Zero Energy Ready certification seems very feasible, right? If you're talking passive house, that certainly is, a step down from that. And so I think about the Inflation Reduction Act and how it supercharged the 45L tax credit, which has always existed, but it sort of supercharged it, right? So now you're talking about like $5,000 per unit. And so the question I'm kind of asking is the structure of this arrangement by which typically there's some sort of owner building this and then selling it to somebody, because that's my understanding of how these tax credits can be realized. Short of meeting the certification, you have to have this sort of like, hey, there's someone who owns it, they build it, and then they sell it. And then that's where maybe there's an ability to claim a credit and cut costs. Is that something you're all looking into as an opportunity?
Yeah, definitely looking into it. And I don't have like a real clear strategy there yet for like how things will be financed.
Yeah, it's one small piece of the puzzle. So
yeah, but I think an important point there I think is that not only are we're not only focused on the operational carbon and the embodied carbon, but also the recurrent carbon. So the dome can be basically repaired and resurfaced with the same material that it's made from.
Yeah.
And so we're designing for basically a 500-year design life. So you'll never have like siding to replace or paint or roofing. And again, it kind of ties into like this regenerative village or regenerative community approach, in that we're engineering communities that are designed to kind of partner with the local ecosystems and be there for a long time.
Yeah, that's great. Well, on that note, we're going to go ahead and wrap up. Morgan, where can people go to contact you or reach out to somebody, learn more about ceramic domes and GeoShip? It sounded like, if I heard correctly, David was saying he went and toured one. Can people go tour one? Can you just tell us a little bit more on where people can reach out?
Yeah, basically, go to our website, geoship.is, or connect through social media. And we're doing kind of limited tours of it's not even a product. We call it like a demo dome, right? It's not but in Q1 of next year, we'll have more open tours of like a go-to-market product, which is a 1,600 square foot, 2-bedroom, 2-bathroom.
Can someone Airbnb there maybe in the future, right? Just stay in it?
Yeah, definitely. You'll be able to Airbnb it.
Sweet. All right. Well, we'll look forward to that. So, Morgan, I really appreciate your time, and Gene Mark, who's been behind the scenes facilitating this conversation and the other Q&As. Thank you. Thank you to GeoShip for having you out. Take care, everyone. We will catch you on our show next week. And for those of you in the United States, have an amazing Labor Day holiday weekend. So be well. Take care, all. Thank you so much.
All right, guys. Thank you.